Hello again. In this segment, we're going to look at how to graph logarithmic functions, logs. Now you might be looking at this image on the screen and wondering, why do I see how to graph an exponential if we're supposed to be graphing logarithms? Well, the reason is simple. Logarithms are the inverse of exponentials. So when I look at an inverse of a function, I know that to find that inverse, all we have to do is switch x and y. That's the relationship between a function and its inverse. And so what we're going to do is look at this procedure that we know for graphing exponentials. And if you haven't learned this procedure yet, then you want to go learn how to graph an exponential before graphing a logarithm. And all we're going to do is switch everything that says x to say y. So to graph y equals log base b of x, where b is greater than 0 and b does not equal 1. What we're going to do is, instead of a y-intercept, we're going to have an x-intercept. And that x-intercept will be at 1, 0. Instead of the point 1, comma b, we now have the point b, comma 1. And instead of negative 1 b inverse, we now have b inverse negative 1. And finally, instead of the x-axis being an asymptote, we have the y-axis is an asymptote. Now, all of this is really only possible because exponentials and logarithms are one-to-one functions. If an exponential was not a one-to-one function, then it wouldn't have an inverse function, and we wouldn't have our definition of logarithm. But it is one-to-one. Our definition of logarithm is what it is, and so as a result, we can graph logarithms immediately if we know how to graph exponentials. So let's do a few examples of that. I'm going to erase the procedure for graphing exponentials here, because that's not what we're doing. We're here to graph logarithms. And let's do that in blue. So if I wanted to graph f of x equals log base b, what should our base be? Our base should be 4 of x. Then what I'm going to do, start by drawing my axes. Again, label those axes x and y, just like we always do. Label the scale. I'm going to count by ones again. But there's nothing special about that. I choose 1 though, because 1 is going to be a point for us that we need, and we're also going to need that point at 4. So this seems like a good scale. We have the point 1, 0. That's right here. We have the point B1. In this case, B is 4, so that's going to be at 1, 2, 3, 4, 1. And we have the point B inverse negative 1. Since B is 4, that means B inverse is 1/4. Thus, B inverse negative 1 is going to be right here. If I subdivide this down, you can see that there's 1/4. And it's going to be right there. Now we can draw our curve. And if you notice, if you remember what it looks like to graph an exponential, this looks just like a graph of an exponential that's been turned kind of sideways. And that's exactly what's going on. Okay, let's look at a second example. G of x equals log base 1/2 of x. Now, because the base is 1/2, that means it's going to affect the shape a little bit, but it's not going to affect our procedure at all. We're going to follow the exact same procedure to graph this. So again, we have the point 1, 0, that hasn't changed. We have the point B1. B is 3, or B is 1/2 this time. So 1/2, comma 1 is up. And then we have the point B inverse -1. B inverse now, the inverse of 1/2 is 2, so that's 2, -1. So that if we go to draw this, it goes up like that. And that's our graph. I want to do one last example. This time let's have a function that's been shifted around a little bit. I'm just going to squeeze this n up here. So let's try m of x equals log 3 of x minus 2. So m of x is going to get shifted to the right 2. What that means is I'm going to need a little bit more room to the right than I do to the left. It's x. Let's label that scale the same. So let's see. Shifting to the right 2, that puts our asymptote right here. Now this time I have to draw the asymptote, which is represented by that dashed line, because it's no longer on the axis. I can't use that existing line to represent the asymptote. So here it is as a dashed line. And now from here, our version of the point 1, 0 is no longer going to be at 1, 0. It's going to be over here at 3, 0. But that's our version of 1, 0. Similarly, B1, which should be at 3, 1, is going to be at 3, 1 based on this version of the origin. So 1, 2, 3, comma 1. And finally, B inverse -1, that'll be 1/3 -1, but again, based on starting here. So if we subdivide that down, there's 1/3 -1. And that's the graph. So if you can shift around these points, or at least our versions of these points, then what you can do is just move things around so that, again, this is our version of B1, which in this case is 3, 1. Here's our version of 1, 0. And down here we had our version of B inverse -1, which is 1/3 -1. And that's it. If you can shift things around, then you can graph any logarithm. Do be aware, of course, if you just have log and no bases written, that means the base is 10. That's going to make it a little bit harder to fit it on the screen here because I'd have to get that scale to go all the way out to 10. But I also want to still have that point 1, 0. And if it's ln, if it's natural log, then the base is e, which is again a little bit harder to work with in terms of drawing the graph because e is something we'd have to approximate. And then the inverse of that is also something I'd probably grab a calculator to get a good feel for exactly where that decimal should be. But that's all there is to it.